All right, I'm going to work the next 5 problems in the 2008 multiple choice non-calculator portion. So I'm going to work 6 through 10. All right, so it says on number 6, let f be the function defined above, which of the following statements are true. All right, so first off, f has a limit at 2. So f is a piecewise function that follows this rule at every point on the graph except at 2. And at 2 it has a different value. So basically you're talking about a graph that follows one rule at every place but at one single point. And so what we're going to have is either a case like this where the graph does something except right here at 2 it's here at 1, or the whole graph does something except right here at 2 we fill this hole with a 1. And the difference is not going to make a difference as far as the limit goes, but it will make a difference as far as the other 2 go. So it doesn't really matter what happens at 2 as far as the limit goes. What matters is what happens everywhere else on the graph. So to find the limit, we just plug into the first piece. Now you will need to factor to be able to plug 2 into the first piece. If you try to plug it in right now, you're going to get 0 over 0, which is undefined. So cancel that out. Now if we plug 2 in, we get 4. So that means that we're going to have this first case where this function follows a rule, and at 2 it has a hole in it at 4. At 2 there's a hole with a height of 4. And then this second piece puts a point at 2, 1. So we're going to have this case here. So there will be a limit at 2. But it's not continuous or differentiable at 2 because the value that we got when we plugged 2 into the first piece doesn't equal the value that you get when you plug 2 into the second piece, which makes it not continuous. And if it's not continuous, it can't be differentiable. So only one is true. All right. Number 7. Got a motion problem here. Oh, hold on. Got a little screen popping up right there. I don't want that. Okay. All right, so number 7, we've got a motion problem. They give us the velocity, and they give us the position, the starting position of the particle. So what's the particle, what's the position of the particle at 1? So we would need to take the starting position, which is 2, and add the total change in position from 0 to 1. So total change in position or displacement comes from integrating velocity. Right. This will give me the total change or the displacement from t equals 0 to t equals 1. So if I integrate that, I'm going to get 3t cubed over 3 plus 6t squared over 2 from 0 to 1. If I plug 1 in, I'm going to get 1 plus 3. If I plug 0 in, I'm going to get 0 plus 0. So basically the displacement is 4. Notice that that's an answer choice, okay, so that's kind of a gotcha answer choice there. 4 is just the displacement, it's not the position. You have to take its starting position and add its displacement to get its final position, so the answer would be B. All right, number 8, we're asked to take the derivative of this function at a specific value. So I'm going to take the derivative of the function, and I have to do the chain rule because I have one function inside another one. I have 3x inside of cosine. So I'm going to do the derivative of the outside, taken at the inside, times the derivative of the inside. So I'm going to get negative 3 sine 3x. Then I'm going to plug pi over 9 in for x. So negative 3 sine 3 times pi over 9 would be negative 3 sine pi over 3. And to do your trig values, remember this big square root that we learned in pre-cal for your first quadrant angles. So if I want to know the sine of pi over 3, the sine of pi over 3 would be square root of 3 over 2. So I'm doing negative 3 times square root of 3 over 2. That would be E. All right, number 9. The graph of a piecewise linear function is shown in the figure above. G is the integral of f. That means that this is the derivative of g. Which of the following values is greatest? All right, so if I plug negative 3 into this, that means that g of negative 3 is the area between negative 2 and negative 3. Right? And because that's backwards, going from negative 2 to negative 3, even though that's above the x-axis, the value I get will be negative. Because to fix the fact that the bounds are backwards, I would have to switch them and put a negative in front. So that area would actually end up being counted as negative. It's a trapezoid with bases of 1 and 2 and a height of 1. So the average of the bases times the height would be 1.5, so negative 1.5. All right, g of negative 2. If I plug negative 2 into here, because that makes the bounds match, that makes this 0. And we're looking for what's the greatest. So we know now it's not A, because what we got on B is greater than what we got on A. Okay, so then on C, we're talking about the area from negative 2 to 0. So we know that's going to be positive, more than 0, so now we know that this is bigger. G of 1 would be the area from negative 2 to 1, so that's going to be even bigger than it was when we just went to 0, because now we have even more area that we've added. And then G of 2, we would go from negative 2 to 2. Well, the difference between negative 2 to 1 and negative 2 to 2, we're subtracting area now. So this is actually going to be smaller than the total area we had between negative 2 and 1. So D would be the right answer. All right. Let's see now, just a little bit here, so I can put that on here. Okay. So this one, the graph of a function is shown above of the following which has the least value. All right, so this from 1 to 3, the integral from 1 to 3 means the total area under the curve from 1 to 3. So the actual area between the curve and the x-axis. The rest of these are all approximations. Okay, so basically they're wanting you to compare these approximations to the actual area. Which one would give you the least? All right, so a left sum with 4 intervals of equal length. So if I'm going from 1 to 3, a left sum I would draw in 4 rectangles, and I would use the height on the left. So I would end up with more area than the actual area. So that's not less. Now, if I do a right sum, I draw in my rectangles. I draw in 4 rectangles. Oops, do it like this. I draw in my rectangles so that I use the heights on the right, which is not enough area, right? So that's definitely less than the actual area. A midpoint sum would mean that I would use the heights in the middle, and a trapezoid sum means that I would draw trapezoids. Well, using the height in the middle is going to get me closer to the actual area than using the heights on the right. And a trapezoid sum is actually the best of all the approximations. So the answer is C. Anytime you are trying to approximate a decreasing function, A right sum will always be the greatest under approximation. If it had been a increasing function, then a left sum would be the greatest under approximation. Midpoint sums and trapezoid sums are better than left and right because they tend to be more of like an average of the heights, kind of more of the middle ground. So this one would be the right sum.